hopefully. I forgot to mention uh, that I also added a video specifically for Chapter 4, Question 19. Now, I know, so it's right here under Chapter 4. Um, it's one question out of the homework for Chapter 4. I know you could skip it and still end up with 90%, but it's a type of question that makes a really good test question. So when you get to 19, I've got a full setup here. I'll just kind of go a little bit through it. There's the question setup. It's using tree diagrams. So that's in there, and I've got it recorded. I did it in my couple classes already um, as I was doing it, but it shows the setup here, and it walks you through how you could set up. Now, your numbers will probably be different in your particular question than these, but it shows you how to set up the probabilities, and not necessarily the slideshow, but the recorded, I actually worked through it. So it's a kind of a short, gets you through the A part, sets you up for the B part, and then you can take it from there. But when you get to question 19, maybe if you want to skip it, you can skip it for the first part, but do come back to it because we'll see it again when we prepare for the test as well. Because it, bless you, it'll test you on about 3 or 4 different topics with just one question. So we'll come back to it. I just wanted to let you know that's available. We're going to finish up sections 5.2 and 5.3, and all it is it's a special probability distribution, and it's binomial distribution. So let's break down the word binomial. What does bi mean? Bicycle, 2 wheels. So yeah, so binomial means 2 nomials. What's a nomial? I don't know. But what it means is that these are probabilities that only have 2 possibilities. And so we'll call them a success or a failure. Okay. And maybe it's not, those aren't the right words, but you get a heads or you get a tails. Okay. Something like that. Anything that has only 2 options, it rains or it doesn't rain. Now, something like that. So that's a way we can set up a binomial distribution. So, and then what is the hallmark of a binomial distribution? If we do it multiple times, so we flip a coin not just once. Oh, you could do it once, but what happens when you flip a coin 10 times? What are all the possibles? How many times could you get ahead? So here we are. So they're independent trials. One trial does not affect the other. Okay, there's only 2 possible outcomes. We call one a success, one a failure. Again, that verbiage might not be exactly correct, but we'll just do it. And usually we label the success, we label that with a little p, and the failure we label with a little q, which p's and q's, right? Mind your p's and q's. And since there's only 2 things that can happen, like chance of rain, if there's a 70% chance of rain, what's the chance of it not raining? 30%, right? So they have to add to 100% when we add them together. The probability of a success does not change with each trial. That's what makes it binomial. If it's changing, then it's a different thing and we can't deal with it. And then what we're going to assign the random variable to is to count the number of successful trials. And again, we determine what we call a success, and whatever that is, we count how many times that thing happens. Okay. So this is just, again, sort of notation or vocabulary. We use little n for the number of times that the trial is repeated. So sometimes we're measuring how many days in a month do we get rain. So number of trials would be 30 days or 31, depending upon which month we're in, or 28 if it was February, right? Little p is a probability of a success on an individual trial. Q is the probability of a failure, and Q is always equal to 1 minus P, right? Because 100% is everything. So they have to both add together to be 100% or 1. And then X is just that random variable we're going to talk about. And the way these questions are phrased is what's the probability of getting 4 successes or 5 successes? Or, so that would be the probability, say X equals 4. Sometimes we want to know the probability that x is less than or equal to 4. Sometimes we want to know the probability that x is greater than or equal to 4. And sometimes it's just greater than or less than. We'll see how we can, but the cool part is the tool handles all of this. And it does it graphically, so you can kind of see it. So if you're one like me who has problems with the direction of an inequality, you'll get a picture that helps with that. Okay, so those are the types of questions we're going to be, once it's set up and we're doing a binomial, we're going to enter in to our calculator, we'll enter P. We don't have to enter Q because our calculator knows that Q has to be 1 minus P, so we don't have to enter that. And then in the tool, we'll tell the tool what X is. Okay, so we'll look at a couple examples. A certain surgical procedure has an 85% chance of success. We've talked about the ACL surgery before. I think it was 95%. I don't, anyway. A doctor performs a procedure on 8 patients. The random variable represents the number of successful surgeries. Okay, so we've got this set up. There's going to be 8 patients. Probability of a success is 85%. That's really all we need to know. So we're going to be able to set it up. I'm going to jump over to the calculator and start showing you how these questions are going to be addressed. The nice part is when this is a discrete probability, we're going to jump into continuous probabilities, and it's just a different tool, but it works very, very similar to this one. So where we go is we go over to distributions, I think, right? Down here, sequence, yeah. Looks like they've reorganized it for some reason. Anyway, we're doing distributions. And we're going to do a binomial distribution. Notice all the different ones it can do. Now, we're not going to do all of these. We will do normal as the other one. That's going to be our continuous one. So we're just going to use 2 of these tools. But if you take a more advanced class, you've got a tool that will handle all these other types of distributions as well. We're not getting there. The chi-square is used quite a bit. Sometimes the uniform is, but again, we're just going to use the binomial and the normal. Today, we're just focusing on binomial. So we'll hit enter. First thing we have to do is how many trials? Well, they said 8 patients. So N is 8. So each patient is a trial of a success or failure. So there's 8 of them. And the probability of success, this is what we always put in, is 0.85. You'll see sometimes it needs that probability of failure, but the calculator will calculate it. So 0.85. That's all we have to tell it. And then when we come here, this is the other part of the tool. It gives us a bar chart. And so you see it's weighted over here. 7 has the highest probability of success. But these are individual probabilities, and I'll show you how this tool works once we get to the question. We haven't even got to the question yet, but we'll come back here. So binomial experiment, N equals 8. We pick that out of there. Probability of success, 85%, 0.85. We could use Q, and again, we might need Q later down when we do the actually 5.3. The last slide, we'll see. We'll do those calculations for standard deviation using this formula. And then the number of successes is 0, 1, 2, 3, 4, 5, 6, 7, 8. And you'll see in our calculator, we have 0 through 8 listed there. Okay, so now we're ready for an actual question. No, they're not going to give us a question, but let's give a question. What would be the probability? So this is what a question might look like. What would be the probability that x equals 7? Okay. Since I've got it set up, all we have to do here, well, this is currently set up for x being less than or equal to a number, but if we arrow over and hit the down arrow, these are the 4 options we have. So x is either less than a number, this is x is between 2 numbers, this is x is greater than a number, and this is x equals a number, just a single line. We want x equals a number. So we just, again, like I said, it's visual. I'm not looking at symbols here. I choose this one, and now I've got x equals. I put in 7. Oh, have to arrow back over to here. I put in 7, and watch what happens. It gives me the probability, so 38% chance of exactly 7 successes. That means 1 failure and 7 successes. And it also shows me graphically here what I've got. Okay. What if it had asked, or what's the probability? And I'll do this because these are the types of questions you get in the homework, that x is, let's just go with less than 7. Less than 7. If x equal to 7, does that count? No. So it has to be less than 7. So for our tool, we've actually got to come here. We don't have, you'll see, there's this one less than a number, but when we come over here, that's less than or equal. We can't put a 7 there. That would be less than or equal. So we have to use 6, right? It's really less than or equal to 6. That's because 7 doesn't count. So that's one of the features you have to kind of watch out for, is you can't always just say less than 7. Okay, I just put 7 there. Nope, you got to put 6. But watch, it'll verify it for us here, and it tells us that's a 34%. If I had put the 7 in instead, because I wasn't paying attention, which I often do, I see that it's including the 7. I go, wait, less than 7 shouldn't include the 7. But I've got a visual here that tells me I'm getting too much, right? 0.72. Oh, this is less than or equal to 7. So just come back and put the 6. So watch for those visual clues. That's why I like this calculator. It's got the visuals down here with the graph. And again, you see these are very low probabilities. It's very unlikely that he would only have 1 success if there's an 85% chance of success with each one. Most likely to be up into here. And so yeah, there's a 34% chance of having 6 or fewer successes. It's actually better. Okay, so that makes sense how the tool works. Just remember, and again, a lot of this is just getting used to using the tool and seeing where the things are. It just drops down. You choose which one, less than, greater than. Between 2 numbers, we can actually do what's the probability of getting between 5 and 7 successes. We could calculate that. Why not? We'll come here, and then x is less than or equal to these numbers. So we could put in 5 and 7. And remember the 7. Sorry, 5 and, where am I? Here we go. 5 and 7. And this is equal to, and again, when I put the enter, there's a 70% chance, 70.6, and I see it's 5, 6, 7. Okay, so you get the visual along with the answer. This is the advantage over a TI-84 calculator, which would just give you the value, but it wouldn't show you the picture. And I was teaching this with one of my classes in the spring with the TI-84, and this is where we started having a lot of problems because their tool, they were guessing. Sometimes they got the right one, sometimes they didn't, but they didn't have the picture. The other school I was teaching, I was using the NumWorks, and they were getting it right consistently because they could see the visual. So that's why I went with the NumWorks. And again, you can download it to a tablet, to a cell phone, to a computer. So it's available to us. You can also order a physical one if you want. They're $99, but which is actually better for a brand new one. TI-84 similar ones about $140 to $180. So it's a better price, but still we got it for free. And when I do with my online classes, I actually am able to embed it in the test, so it's right in there. Okay. So that's, now we basically, you know everything you need to know about this section. So we're going to go a little bit quicker through it, but that's exactly the same steps you're going to take every time we have a binomial distribution. How many trials? What's the probability of success? What's the probability of failure? You calculate that, and then what are the possible values? And you know, however many trials there are, it could be any one of them in between. The jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacement. The random variable represents the number of red marbles. Is that a binomial experiment? Think about it. What would be the probability of getting the first red marble out of the jar? Well, there's 5 red marbles, and how many total marbles? 5, 9, and 6, that's 20. Thank you. You're fast. So that would be the probability of getting the first red marble. What would be the probability of getting the second red marble? Since you're not replacing it, there's now only 4 red marbles and only 19 total. Are these probabilities the same? No. This is not binomial. Remember, binomial needs the probabilities to stay the same. If I was replacing, then it could be a binomial experiment, okay, because the probabilities would stay the same. So anything without replacement, it's not binomial, right? Its probabilities are changing. Okay, so that's one of the things is most of the questions in this section are going to be binomial, so you're pretty safe. There'll be a few that'll ask you, is it binomial or not? But otherwise, they're giving it to you. But down the road, you might not recognize. And so we've got to use, especially this one. Remember, we did this kind of question back in chapter 4. So on a test, if I ask this, you just have to know that that's not binomial, so you don't use the binomial. So that's part of what you're going through here is you've got to navigate the different types of questions and which tool do I use on which question. That's the main thing you need to be able to say. Okay, so not into it. Here's a rotator cuff surgery, 90% chance of success. The surgery is performed on 3 patients. Find the probability of the surgery being successful on exactly 2 patients. Now we were doing this before, and we could multiply them, right? We could say, okay, there's a 90% chance of success for the first. They're independent, a 90% chance for the second. And then we would have had to say the third one was not successful to have exactly 2. So that would be 10%. So we could calculate it that way, or we can use our, since we hopefully see that this is binomial, it's independent, the probability is not changing, we could also come to the calculator, back up. Actually, I'll go all the way back, right? Distributions, binomial. We're doing 3 surgeries, so 3 is the biggest, and it's got a 90% chance. And then when we come here, we want exactly 2. So we use this tool, which is going to give us the exact value. And we put in 2. And it tells us that's a 24.3%, 0.243. And we see the picture here. Probability of a success, 2.43. Also, I'm just going to verify that if we did it with the calculator, it was 0.9 times 0.9 times 0.1. 2 successes and a failure. Actually, this won't give us the right value because we've got to do the combination, because it could have been the first one was not successful or the second one was not successful. So we get 0.81, and you're going to have 3 different ways to organize this, right? First one was not successful, second was not successful, third. So then if you take this number times 3, because there's 3 ways to do it, answer times 3, that's the 0.243. But notice we had to really think through this, right? Now we don't have to. Our tool, the binomial tool here, takes that all into account for us, 0.243. I didn't have to think how many different ways do I have to do it. And we're going to see there's kind of a big calculation tool. I mean, if you do this by hand, you're having to do combinations and permutations and then probabilities. So I'll show you that in a moment, but we're going to be able to skip over most of it because we're going to use this tool, which will do it for us and allow us to focus again. What does this mean, right? It's about a 24% chance that exactly 2 surgeries are going to be successful. Now, if I wanted 2 or more, or 2 or less, let's do 2 or more. That's the greater than. And notice it's greater than or equal to 2. That would mean 2 successes or 3 successes. I got it, and I see the 2 lines that I'm counting both of those. I've got a 97% chance that I'm going to get either 2 or 3 successes. Okay, but I didn't have to think about all the different ways to do it. And you're going to see sometimes there's a lot of calculations if you do it by hand, but if you do it here, the tool has that all built in. Okay. So this is one way they went about doing it, right? They use the tree diagram, which if you question 19, that's built into it, but you'll see we don't need to do it. Okay, they had a failure was last, the failure was in the middle, the failure was last, so 3 times this value. They got the same value we did, just directly with the tool. Um, this is the formula you would have had to use, and I remember learning this. This is how I had to do it. Probability of success, probability of failure, and then the combinations of all the ways you can combine them. And having this tool, again, gives us that visual, but it also did all of these calculations. Watch this calculation, what it ends up looking like. Probability of exactly 2. This is the combination of 2. How many ways can you combine it? This is the probability of success, probability of failure. And again, it comes up with the right answer, but you had to remember this formula. If you've got a numworks, you don't have to remember that formula. You just go to the Binomial app. Okay. But I like showing you those things. Okay. Calculating a binomial distribution. So that would be a table of values with all the possibilities. And again, I'll show you how we can do that relatively quickly with this. Okay. So we're told the probability of success is 0.48. N is equal to 6, so that means there could be 0 successes, 1, 2, 3, 4, 5, 6 successes all the way up. And so we go back to our probability tool, or our binomial distribution tool. We just put 6 for the number of trials, 0.48 for the success rate, and then we get this distribution laid out for us, and we can calculate what each of the probabilities are. So the probability that there are 0 successes is 0.019, or about 2%, right? I can change this to 1, and I get about a 10.9%. And I'm going to show you that that's what they're going to calculate, but you're going to see it's a lot more to calculating. So I would write this in the table that I'm making. Then I could change it to 2, enter. It's a 25% chance. 3, that's a 31% chance. So I could write, again, I would just put these numbers in that table. I believe there's a homework problem similar to this. And we calculate the 4, 21%, 5, 7.9%, probability exactly 6, about 1.2%. Okay, so kind of remember those numbers. This is how you would calculate those by hand. You would do all of this, and there's that point, that's a 0.2%, right? We had 0.019, but if you round it, it becomes 2%. Here's what the calculator got for us. But again, you would have had to use this formula to get there. This one, this one, this one, 5 and 6, and I go back, the 6 is the last one we did. So those values we're able to get from using the numworks app. Okay, so please do use it. But again, remember how to get there. You're going to go to the menu, distributions, binomial, right? You're starting here, come to distributions. This is going to be your best friend for the next few sections, actually into chapter 6 as well. And then you have to enter in, this is all we have to enter, the number of trials and the probability of success. Everything else will be built into here. And then it gives us, and then we just have to choose whether we want the probability of it being equal to a particular number of trials, greater than, between 2 numbers, or less than. Okay, and that's the homework is going to have you do several of these. Again, for you, it's going to be a really quick calculation because you just come here and do it rather than doing this. And if you wanted like less than 5, then you would have to come back and add all of these together. You'd have to use each individual one. This tool is so much nicer. Okay, and you'd have this. Notice there is a slight rounding error. We just got 0.99. We didn't get to 1, but that can happen. So it's okay. If we went to 4 decimal places, we'd probably get exactly 1, not the rounding error. Okay. So let's see how quick and easy it's going to be now. When you get a homework problem, they're going to give you a success rate. So found that 22% of U.S. adults said that economy, unemployment, jobs are the most important problems facing the U.S. today. You randomly select 4 adults. So watch for that number. How many people are we choosing? 4. So that's our N value. That's for our binomial. Ask them whether the economy, employment, jobs are the most important problems facing the U.S. Find the probability that exactly 2 of them respond yes. Okay. So again, no formulas to remember. We just come here, 22% success rate. 4 is our number, so we back up. We put in 4 for the number of trials, 0.22 for our success rate. And then when we get to here, we want to find exactly 2. We come here. We just need to come over to the graphical, and we have to come down here. The single line is exactly equal to a number. And so we do that, and then we see the symbol in between is changed to equal. So we put 2, 2. Oh, got to arrow over to the input there. So now I'm inputting here. And I see graphically I'm getting just 2, and it's 17.6%. 17.7 if you round it, right? Cool, done. No formulas. At least 2 of them responded yes. At least 2, what does that mean? Oops, not that one. At least 2 means 2 or 3 or 4, right? Bigger than 2. So all I got to do is come over here, change it to this one. Here's at least 2, so it's more than 2. Greater than or equal to 2. That's a 21.2%, and I see the 2, 3, and a little bit of the 4. It's such a small probability. Okay, but that's the probability for that one. And then fewer than 2 of them. Now, fewer than 2 does not mean 2. 2 responded. That's 2 is not fewer than 2, right? So this is the hard part, is reading the English. That means 1 or 0. Okay, fewer than 2. So when I come back here, I am going to use the less than tool. But notice, since it's less than or equal to, I don't want to put a 2 in here. I want to put a 1. Okay, because fewer than 2 would be 1 or 0. And when I do that, I see I got 1 or 0. If I forgot and I put in the 2, I would see down here the 2 was included, and I go, wait, no, I didn't want that one. Okay, so check the visual part as well. 78.7% chance of getting 0 or 1 person. Okay, so notice how we were able to answer those very quickly. We were using the formulas. We could get used to it, but it probably would have taken 10 minutes because you got exponents and there's easy ways to make mistakes and so forth. But we're fine. Like, this is how you would do it by hand. So you want to do it, more power to you. Use the formulas. Look at this one. To calculate more than 2, you would actually have to do 3 calculations, add them all together to get the same number we got by just clicking and going there. So that's the beauty of this particular app. And again, other calculators, statistics calculators do it, but you have to use, it's almost like coding. You have to know where to find the feature. You have to put it in just right, and then you also don't get the visual, so you're not quite sure if you're including the 2 or not including the 2. You just get the answer, but here we're giving you the answer and the visual of exactly what that answer is including. Okay, how many numbers. Okay, and this was the last one, less than 2. Again, you're finding 0 and 1. Again, that would have been 2 calculations up here, and then you would have had to add them together. Again, we were able to do it all visually. And what that allows us to do is, with this tool, to focus on the question, right? Remember what we're doing. A lot of times when I got into the calculation, by the time I'm done with the calculation, I didn't even know what I was calculating anymore. I got 78%, but I have no idea what it means. This time I know, oh, that means it's 0 or 1, because that's exactly what I put. You're closer to putting in the value, getting your answer, and you remember what you're working on. Okay, and that's the kind of tools you need when you're in a management position or you're in a research position. You want to focus on the question at hand. You don't want to be doing math on a napkin somewhere that blows off and stuff, and maybe you make a calculation. Or even our scientists, I don't know, this, I think it was a Hubble telescope. They were sending this multi-million or billion-dollar telescope into space, and there was a calculation error because Americans were working with another country, and some were doing it in metric and some were doing it in inches, and they didn't do the conversion right, or they didn't convert something. But that little error blew the whole project. They would have been using a computer that they just put it all in, and they would have had set up to all use the right units and everything. Perfect. But they were trying to be, I don't know, show how much math they could do, and they blew it. So sometimes just let the calculators do it. In fact, I have a friend who I've worked with at Scottsdale Community College. He was an engineer for years and became a math teacher. And he would tell us in the department, he says, you know, in engineering, nobody is interested in your hand calculations because that's what they thought math was. He says, we want to see it run through a computer. We know humans make mistakes. So we don't want to see hand calculations. We want to see it run through a program. And I agree with them. Okay. Let's see this one. 5% of workers age 60 and older in the United States commute to their jobs using public transportation. You randomly select 8 workers. Let's back up. Again, this just be one more example. 8 workers, 5% use public transport. What is the probability? Exactly 3 of them use public transportation. 3 of them. So probability of success is 5% do it. There's 8 workers, so 8 is our number. Probability of success 5%, and we're looking exactly equal to 3. Again, it's really quick calculation for us. We just have to back up. We put in 8. We put in a 5%. And we come here. We choose our equal tool. There that is. And we put in the number 3. And we see that that's less than 1%. You can't, there's a little color down there, so you can see down here. So the probability that 3 out of 8 is a very small probability. It's less than 1%. It's actually only 0.5%. But they will do the calculations for us, but they would be long. So this is the last part. And this one we have to do a little bit by hand because now if somebody finds this tool within NumWorks, I'll give you extra credit because I haven't found it yet. But I don't want to say it doesn't exist because sometimes it does exist. It's just because I didn't find it doesn't mean it's not there. But I haven't found this. So when we want to calculate the mean and we have a binomial distribution, the way we do that is we take the number of trials times the number of successes. That's it. So n times p. We'll do a few of these. To get the variance, it's this formula, n times p times q. That will give you how much variation is in there. And again, we could spend some time talking about why this works, but I tell you, I've read all the pages and stuff, and it still didn't really help. Didn't really make a lot of sense, but it does give us the variance. And then if we take the square root of the variance, it'll give us our standard deviation. And again, I'm a math major, and it's still a bit of a mystery to me, but I just know it works. So I'm the kind of guy who says, if it works, I'll just do it. I don't have to understand everything. I know when I turn the key on a car, it turns on, or most of the time. I don't need to know all the specifics of this goes through a relay and stuff. I'm not a mechanic, I'll let the mechanic figure that out. So here we go. We're going to do this. In Pittsburgh, Pennsylvania, about 56% of the days in a year are cloudy. Find the mean variance and standard deviation for the number of cloudy days during the month of June. Interpret the results and determine unusual values. Okay, so what you have to see is this is I don't know that it would actually be binomial, but the way they set it up, 56% of the days. So we're going to assume that that's each day is independent from the day before it, which we know it's not. If you got a cloudy day one day, a lot of times that you'll get a cloudy day the next. But okay, we'll say it's binomial, 56% chance of success. I don't know that a cloudy day is a successful day, but that's how they phrased it, right? Number of cloudy days. So 56% chance of getting a cloudy day. June has 30 days, right? Or is it 31? I think it's 30. And I looked ahead. So that's what we need. And then what is Q? Q is a probability that it's not cloudy. So that would be 44. We're going to need that to calculate the mean, variance, and standard deviation. So the mean was simply that formula of n times p. So we're going to take 30 times 0.56. Again, maybe this is why there's not a special feature for it, because it's not too big of a deal. So for this one, I'll just go back to the regular calculator or calculation screen and do 30 times 0.56. That's going to give me the mean. So 16.8 days. So in June, I would expect an average of 16 or 17 days, probably 17 days of cloudiness. And again, it's either cloudy or not cloudy. I don't know if that 0.8 means that it was cloudy for most of the day, but not all of it. But we'll just say we'll round it to 17 days of cloudiness. Okay, so the calculation came back with 16.8. Say that's approximately 17 days. Okay, variance. So this is mean. The variance is going to be n times p times q. So we're actually almost there. We just come back to our calculator. We can take this answer, which was n times p, and then we just now need to multiply it by q, which was 0.44, n times p times q. That's going to give us our variance, which is 7.39. Remember, the variance we don't really use for much of anything. You do in a little bit more advanced courses, but for us, we're not using it. We just use it as a step to get the standard deviation. So to get the standard deviation, we take this answer, we take the square root of that answer. So I'm going to do square root of the answer, 2.72. Standard deviation, NPQ, square root, 2.72. So we could say average 17 days plus or minus 3, right? 2.7, rounded up. And that it would be unusual to be more than 2 standard deviations away. So we could say, okay, on average about 17, add 3, so that would be 20 days. Add it again, and you'd be at 23. Subtract 3 gives us 14. And then subtract 3 again, 11. So if you had fewer than 11 days, that would kind of be an unusual June. If you had more than 23 days of cloudiness, that also would be unusual, because that's more than 2 standard deviations away. That's what we use this for. Okay, so average is about 17, plus or minus 2 standard deviations gets us down to 11. So probably not going to get it'd be very rare to get a June that had no cloudy days. Okay. Expect about at least 11. Other than that, it's going to be strange. So they do the calculations. Maybe I'll clear off my screen here. We'll see. Oops. Clear the ink. Let's see. I think that. Yeah, 16.8. That's what we got. Usually multiplication. So these ones you do have to kind of remember, have written down. Remember, you still get your page of notes. So these are the types of things you're going to want on those page of notes. So binomial, if I need the mean and the standard deviation, have these formulas, 7.4, and then standard deviation, take the square root of that, about 2.7. That's what we got. And you could go through and, yeah, notice they take 2 standard deviations below, just 2 standard deviations above. So anything less than 11 cloudy days would be unusual. Anything more than 23 cloudy days would also be unusual. And that's what we use statistics for. Again, to find what's usual, what's not. Okay. And it can help, maybe in the case of your child, the growth rates. That's what we use that for. Make sure they're on track. And again, there's variations in everything. But we just want to see, are we within a normal, what's considered usual, or are we in the extremes and maybe we need to do something? So those kind of things, or is climate change coming? That's how they talk about climate change, because we're getting unusual numbers compared to previous times. Okay, dinosaurs went through that and wasn't very helpful for them, was it? No, that's why they're not here anymore. But hopefully that doesn't happen to us. So you got your tool. Again, use that tool and work to understand what we're doing. Binomial is success, failure. Those are the only two outcomes, right? And it allows us to figure out how many successes we could get, not necessarily in a row, but out of this many trials, how many times will we succeed? It doesn't matter the order. And we've got a great tool that will handle it, because the calculation itself, it's a little complex. It's not that we can't do it. I was able to do it, but I made a lot of mistakes along the way. And I'd rather have you focus on what the meaning is, because you get into the calculations, you lose track of even what you're doing. So hopefully you'll be able to keep on track with that. So that is most of chapter 5. Let's see, where are we going next? Where are we? Back. Remember, so we did 5-1, 5-2. So yeah, what we're going to talk about on Thursday is the normal distribution, which the tool looks very similar, but this is going to be for continuous distribution. So things are happening. So it's more dense, but it's very similar to this. And you'll see. And we've got a tool that handles everything. But that's the big concept that you will use for introductory statistics, is the normal distribution. And we'll spend 2 days on it, and then we'll get into our practice test. And then 2 weeks from now, it's time for our next test. Next opportunity to show how much you've learned. Okay. And boost those grades up. Do well, and remember, there's always that benefit. Just study for this. There's some practice tests already if you want to take a look at them. Use the tools, practice, do better, and remember, get at least a C or better on test 2, and if you want to retake test 1 completely so you can get 100%, we can make that happen.